This is the presentation of the Post-16 Engineering course by myself, Mr. Coxhead, and Mr. Simpson-Baker. So first of all, welcome. I'm just going to ask a few questions just to get you thinking about if this course is something that you'd be interested in undertaking over the next couple of years. So are you interested in solving problems using science, maths and engineering design skills? Do you enjoy learning about the latest technology? Are you considering a career in engineering? And are you interested in studying an area of engineering or technology at university? So if you answered yes to any of those questions, then you might be interested in studying post-16 engineering. So just going to have a look at some of the entry requirements and the course structure. So first of all, a grade 6 in maths and science and a grade 5 in English is a good entry point for the qualification. Just means you're able to access some of the content and able to generate your technical reports, and also being able to use your problem solving skills with using your maths and science. On top of that, really, you need to be self-motivated and driven, persistent, and up for the design and make challenges. Enjoy problem solving using your maths and science skills. In terms of the unit structures, it's a 2-year course. It's Unit 1, Maths for Engineering. There's Unit 2, Science for Engineering. Unit 3 is Mechanical Engineering. Unit 4 is Electrical and Electronic Engineering. Unit 10 is Computer-Aided Design. And finally, Unit 22 is Engineering and the Environment. So Unit 1, Maths for Engineering. So this is where students are going to be developing a range of techniques to solve mathematical problems in engineering. So for example, looking at algebra, geometry and graphs, exponentials and logs, trigonometry, calculus, statistics and probability. This is assessed by an exam, a 60-mark exam, and it's 1 hour and 30 minutes long. Unit 2 is Science for Engineering. So this unit will develop learners' knowledge of the principles of engineering science and also considering how they're applied to a range of different engineering contexts. So they'll be looking at the SI units and measurement, principles of mechanical and electrical engineering, properties of materials, as well as basic principles of fluid mechanics and thermal physics as well. Again, this is assessed by an exam, 60-mark exam. It's 1 hour and 30 minutes long. Unit 3 is Mechanical Engineering, and this is where students are going to explore mechanical principles and how they're applied to engineering systems. So throughout this unit, we'll be looking at forces and types of loading, geometric properties of mechanical engineering, levers, pulleys and gearing, properties of beams, as well as principles of dynamic systems. It's assessed again with an exam. It's a 60-mark exam and it's 1 hour and 30 minutes. So Unit 4 is Principles of Electrical and Electronic Engineering, and this is where they're going to be looking into principles that underpin the engineering of those systems in electronics and engineering. So for example, alternating voltage and current, electric motors and generators, power supplies and power systems, analog and digital electronics. This is the final piece of unit of work, which is assessed by an exam, and it's 60 marks and it's 1 hour and 30 minutes long. Unit 10 is a design skills unit where they're going to be developing computer-aided design, and they are going to be working on 3D assemblies, solid modeling, 2D CAD engineering drawings, and then developing skills using simulation tools as well, such as thermal analysis, stress analysis, etc. And this is going to be assessed with a portfolio of work, so a presentation with all their design work on, where they're going to describe the different types of tools and commands they used to create those designs and assemblies. Unit 22 is Engineering and the Environment, and this is where we're going to be exploring current global issues, as well as looking at some of the solutions which are currently out there, and also potential future solutions to global issues. So they'll be looking at the context of sustainability in engineering, how renewable energy may contribute, and the potential of renewable energies to the global environment. Evaluating performance locally and nationally and globally, and how that applies to engineering. Arguments of engineering for environmental and global manufacturing, and how innovation is making a difference in the way that engineers interact with the environment. Again, this is assessed through a portfolio of work, which is internally assessed and externally moderated, and then that is basically the second of the 2 portfolios of work which students will submit. So some comments from post-16 engineering students. It's an interesting and fun subject. Teachers are very nice and supportive. They like the portfolio of engineering work that they do, particularly the CAD design. Students are very proud of their CAD designs that they generate and develop. And then it also allows them to broaden their creativity across a range of topics. So this is only a snapshot really of what we're going to be covering. So if students would like to talk to myself or Mr. Simpson Baker in school time, in lesson time, you know, at lunch times, etc., that's absolutely fine. I'm sure there's lots of questions that people might have. So again, if people at home would like to email myself or Mr. Simpson Baker, and we'll do our best to get back to you and answer any questions that you've got. But please do feel free to contact us. We're more than happy to sort of talk you to about any more in much more detail about the units or any of the work that students will be completing. So hope to see you next year. Thank you for watching, and please get in contact if you want any more information.